normal reference diet. That is my final shot. So take home message, imaging technique helps decision making in complex cases and saves both time and hardware. So what should I do? Should I do rota, orbital, or should I do scoring balloon, cutting the bone? Proper planning and tools should be used to deal with calcification and bed preparation should be done optimally before placing a stent. Never put a stent before dilating properly in a calcification, and you will be stuck. It's better to do it and send it to some center for rotation. And importance on post-stent MLA by IVAS is placed as it determines the long-term outcome. And this is the algorithm we don't know. Thank you.
Management. Due to time constraint, we are with speaker. Ladies and gentlemen, I would like to invite Professor Dr. Saidul Rahman Khan, who is going to talk about calcification and magic wand. Professor Dr. Rahman Khan.
Remember, we are 7 minutes lag behind, so I think. But you can take time because this is free dinner time.
I'm just going to present in a different perspective because it's about calcification. So let's see in a different way that arbitrarily, if you face a ghost, then what you do, you may need a magic wand, right? And that's why my lecture is about the hidden ghost and the magic wand. I'm just presenting one case that is the patient is 70 years old and with all the risk factors there, and this time with the class 3 angina, and ejection fraction is preserved. But his past history 2 years back was quite chaotic because he had suffered an inferior mind, thrombolized, and then transferred to a PCI center, and 36 hours after, and then is taken to the cath lab immediately, and at the same day. And if you see the angiogram, the left system angiographically showed diffuse calcification, which is expected for a 70 years or more than 70 plus old patients, but with no significant lesions. And at the same time, if you see the right system, which we are expecting because that the patient had an inferior mind, you see what a mess is there. Let's say it's a tight lesion there, it says totally occluded almost, but this is there is a flow. And very interestingly, if you see that the total occlusion of RCA along with a chunk of calcium 5 millimeter beyond the occlusion, which I have shown here. And after that, you see a epicardial collateral, region collateral is there, which is supplying totally the distal RCA. So how the inferior myelus has been happened, and actually after thrombolysis what has been happened there, we don't know actually, but it's said to say inferior myelus, and it's due to RCA, no doubt about it. And the calcification, you can angiographically you can see there, how much is the calcification. So it's quite surprising there, and that can predicted not to be a CTO. The operator, because it was not the same operator, went on with a good faith in fresh MI setting, even with the faith that the calcium could be managed by conventional means, as no other means was there in the shelf. So at least they've taken an Ikari right 6-bench guide catheter transradially for deeper intubation, and also wedding was also difficult, which was predicted, and needed low hydrophilic penetration force WAC with microcatheter, and after that wedding was possible, and a bit of granuloplasty followed by the modifiable balloon. So I have used it, escalating the balloon up to 2.5, 2.75, but further armamentarium of the for calcium needed, but not on the shelf. So then the 3 into 12 millimeter disc, a small disc was tried to deploy, but you see that extensive calcification beyond the occluded segment has moved the stent a little bit upwards. You can see here. And the final picture, and the operator has stopped there, but at least T3 flow is there. Almost 2 years, the patient remained asymptomatic until the last 3 to 4 weeks when, and it is how and why, how it has been so much. Slightly modified calcium at that time, 2 years back. And you know that Renu Girmani's that beautiful thing is there, that some deep calcium has got some insulating effect rather than has got some propensity towards, say, acute coronary syndrome. Maybe that is one of the reasons. But at the same time, the malapposed and asymmetric stand deployment, which has been happened 2 years back, you see the prepared calc OCT substudy, the recently been published. If it is there with the asymmetric stand and a malapposed stand, in that case, thickness of the calcium will be increased, and also the length of the calcium will also increase, which we have seen here 3 to 4 weeks after when we got the angiogram. But this time, with all calcium antagonistic weapons in shelf, we went for hunting. So left system remained the same as it was before 2 years back. And in despair, the RCA has this pathetic picture, though not unexpected that this would happen 2 years after, but at least not occluded. But you see that the stanter segment is there in the proximal part of the stanter segment, and distal part of the chunk of the calcium is in situ there, but we at least T3 flow or T2 flow. So you see that picture in the freeze picture, the stanter segment is there, and then the red one is the calcium chunk, which is still there in the same way. So all options are open now for the calcium augmentation. You need an IVUS, you need encebalo, you need scoring, rotablation, IVL, guided solution catheter. Everything you should have, and these are all in the shelf now. So it's old wine in new bottles, so planning can be very much easier. Imaging to assess the calcification, OCT obviously is better, but OCT is not available, so IVUS. And if IVUS catheter not crossed, then meticulous balloon preparation you have to need. And even then, if not crossed, rotablation, that's a big question for this case. So what we have done, we have gone for the IVUS catheter was not crossed naturally, so we went for a MD dilatation, and after that dilatation, you see the dot coning effect is there. The Gramdy dot coning is still there with the 2.5 inch balloon. And further escalation of the balloon diameter was not possible. We can't take any bigger balloon because it was not crossing at all. So fortunately, IVUS catheter was crossed after ballooning, and then IVUS is showing this freeze picture. You can see the napkin even somewhere, in some pairs, the stents are not opposed at all. In some segments, almost 360 degree and minimal crack after ballooning. So now which one to pick? To pick IVL, you have to pick and rota, or a plain rota tripsy. So what you will have to do that. But mind it, an asymmetric stented segment is there. So rotablation should be the most desperate option if all else fails. So here is the magic word. I am telling the IVL, then which diameter for this lesion? That's a big question and talk of the town maybe. 1:1, it has been written in the literature, but you know, the crossing profile of an IVL is not like the normal or the NC regular modifiable balloons. So I have chosen a 2.5 12 millimeter and 10 pulses per atmosphere, still it didn't work. 10 pulses per atmosphere again 3 times. Then we have gone for 10 pulses 6 atmosphere. And then after 10 pulses 6 atmosphere, fifth time, this time beaten, this time the calcium possibly. So post-IVL IVUS, if you see that beautiful and sweet cracks everywhere. This is like I used to say that cracking ice cream. It's like just it's just oozing there, the calcification by the shock wave. After further dilatation by AC balloon, stenting down easily, and this time 331 deaths, and post-dilatation of course also down. You see that after IVL, the MLA has been 70% of the perfect MLA that should be, and after stenting almost 90%. And then the final IVA speed is also very beautiful here. So what I can say that calcium management modalities are in great evolution. Evolution there, and lots of trials starting from 2013, the Rotaxas, Orbit 2, Prepare Calc, it is CAT 1, this is CAT 2, and then the CAT 3 30 days, and the CAT 3 recently the 1 year outcome. And these are telling that calcium is within our management philosophy. And to me, IVL seems like a smooth, soothing violin. Because unlike atherectomy devices, which our previous speakers has told, IVL requires no specific training. The risk of atheromatous embolization is less, and plaque modification is not subject to diluent bias. Effective circumferential modification of the calcific atheroma is possible, and low atmospheric pressure balloon inflation, minimizing mechanical vascular trauma, and obviously SP protection, side branch protection is easily possible keeping another wire there. So to wrap up, I can tell that the IVL has got some mechanism which the physicians, physics, you need to know. I don't know that much, but these are the terms that the IVL causes that calcium breakdown by squeezing, then cavitation, then fatigue, and then spallation. And after that, calcium will be cracked. So that's the essence and the beauty of the IVL. Thank you very much. Thank you for your patience.
Thank you, Professor Saidul Rahman Khan, for your excellent deliberation. Due to time constraint, we are not asking any more questions. May I request Professor Imad Shiban to give his comment and conclude the session.
Fantastic section. We have seen really very challenging cases. We have learned a lot. So I thank all the speakers and the audience, and have a nice evening.
Thank you, audience, for your active participation, and also my co-moderator, Dr. Murali. Thank you very much. Have a wonderful evening.
Ladies and gentlemen, there is an announcement. An exciting raffle draw is waiting. So those who do not collect the raffle, so you should collect. You never know, you may miss the first, second, and very exciting prizes. After that, cultural program and dinner. Thank you.
Hello.